everyone, all you young Java initiates. It's the Java Meister, Mr. RD, and today we're going to be finishing up our series of videos on introducing object-oriented programming. And our first topic today is a good one. It's called inheritance. And inheritance is really all about the birds and the bees and what happens and how, just like you guys can inherit traits from your family, in Java and in many object-oriented programming languages, you are able to inherit traits from other classes so that you can make a better class by utilizing some of the methods that happened before and adding your own methods to it. And that's the general concept behind inheriting. Is that if you had, for example, a square class and you wanted to create a cube class, rather than starting from scratch, you could actually borrow all of the information from the square class, the x and the y, the width, even the formula for area to calculate the area of a face. You can borrow all of those methods and all of those variables, take them in, and add your own stuff to it. Add another variable for the z axis. Add some new methods to calculate volume and things like that. So that's the principle behind it, and it turns out that it's extremely easy to do this in Java. And there's really just one key word that you need to remember, and that key word is extends. Whenever you want to borrow or to extend another class to inherit its traits, you are going to use this key word. And it's really easy. Here's an example. If I had a public class robot, and this poor robot was able to turn left and it was able to move, but the programmer failed to implement a way of turning right. Well, if I wanted to then go and create a super robot, all I would need to do is create my class just like normal and then add these words extends robot. And what that means is this super robot will be able to turn left, it will be able to move, but it will now also be able to turn right. And when you think about it, that's a fairly powerful tool to have. If you feel like Java didn't implement some important methods for string, go ahead and borrow everything from string and add in your own methods to enhance it. You can do that with most classes using just the simple keyword extends and then adding in the information that you want into it. So if you want, you can pause the video now and you can actually try this yourself. If you've been following along with these examples and you have a square class, go ahead and extend it to create a cube. Add an extra variable just to get a feel for how that works. Do keep in mind that when you create this extra cube class, you're going to want to create new constructors for it. But because you're borrowing from the square class, you can also use those constructors as well. And that's a bit of a topic that goes beyond kind of an introduction to object-oriented programming, but there are still a lot of subtleties with inheritance that we're not necessarily going to discuss right now. So by all means, pause, give it a shot. But in 5 seconds, we're moving on. 0. Okay. So the other topic, there's actually 3 topics that we're going to go over today. We're really going to wrap things up. And this topic is called polymorphism. It's a really complicated term for a really simple concept. And the idea of polymorphism, which is poly for many, is just the idea that you can have a method with the exact same name but doing different things, right? So the example given down here is that I can have 2 methods both called setCard, and that seems counterintuitive because really you should only be able to have 1 method per name, but the catch here is that these methods have to have different parameters, right? Think about it from the program's perspective. It needs to unambiguously know which method to go to. And the only way to do that is to give it a unique set of parameters. Now, this is not a new concept for you. The name is new, but you guys have seen this time and time again. Print line. When you go to print line, you can print line with an integer, you can print line with a string, you can print line with a double, you can put all sorts of stuff in there using the same method name. And that is the concept of polymorphism. And now you have a very complicated term to describe something you've been using for a very long time. So lock it away into memory. Again, if you want to go back, you can look at your class, and you can try to create two translate methods. One that will translate just a point, and one that might translate take two integers. So it's like rapid fire today, I'm telling you. The last one I did honestly save the hardest object-oriented programming concept for last, and it's going to be a bit of a stretch for some of you, but because we're going to be seeing these later in the course, it is important to cover them. And they kind of go hand in hand, which is why I lumped them together. And one is called interfaces, and the other is called abstract classes. So without further ado, let's have a look at this. So the best way of thinking of an interface is to think of it like a template. There might be certain things that are common to a bunch of classes. There might be all those classes may have certain methods that tie them together. So for example, if you think of a polygon, there are certain things that all polygons might have in common, like area, or the fact that they might have at least one point, or the fact that they have a perimeter. An interface is just giving a name to those common behaviors so that any polygon that you create will conform to that interface or to that name. Let me give you a few more points about that. So the point of an interface is strictly to define certain methods. There's no implementation details. There are no variables inside it. All that it does is define certain methods, and it does not give any of the implementation detail for them. What it does do is it says that any class that uses this interface will be guaranteed to have these methods in it, implemented in some way. So that's kind of useful, because if we create an interface of a polygon, and then we go on to create squares and rectangles and triangles and all those sorts of things, if those classes that we create use this interface, we can know guaranteed for sure 100% that they will have methods that were included in the interface. We know for sure that they will have a method to do area and a method to calculate perimeter and all that sort of stuff. The way of doing it, again, it's really easy. In your development environment, instead of creating a class, instead of public class shape, you're going to create something that says public interface shape. And that's actually the predominant difference here. The only other slight difference is that you'll see that you can have methods inside here just like normal, except there's no implementation. You just lay out the method, you put in the parameters if there are any, you put in the return type if there are any, and then you end it off with a semicolon. Done. End of story. The other type is called an abstract class. And it's very, very, very related, because it's just like an interface, except it tries to find a middle ground between an interface and a class. So what it does is it says, you can have some methods that aren't implemented, but if you want to implement some, go right ahead. Also, if you want to add some variables in there, go ahead and add those too. But again, the idea of the abstract class is that anything that follows or utilizes this abstract class will have access to those variables, will have access to those methods that were implemented and must have the abstract methods there. Java has a bunch of these. They have a bunch of interfaces that are really important to programming that you're going to use, and they also have a bunch of abstract classes as well to help out. So here's another quick example: public abstract class shape. You can take any class that you want and you can add this word abstract to it, because an abstract class can have implementation. So the only reason that you'd want to turn a class into an abstract class is because potentially you want to have some things that aren't implemented but need to be there. So the big question for this topic is why? Why not? I could say, but instead I'm going to demonstrate for you in NetBeans some of the reasons that you might want to use abstract classes or to use interfaces. And it turns out that there are some powerful reasons, and we're going to jump in and have a quick peek. So I've created here a really simple object-oriented program. We have a square with nothing in it, and I have a program that creates a single square. Just for the fun of it, we're going to create another class in here, and we might as well call this one rectangle. And with a rectangle, if we wanted to, we could create a rectangle here to help us. Now, what does this have to do with interfaces and abstract classes and all that sort of wonderful stuff? So let's say that we wanted to have something to find commonalities between rectangles and squares. So one way of doing that is I could come up here and I could define a new interface. And I could call this new interface shape. And if you remember, the properties of an interface are that I cannot have variables. Not happy. But I can have methods. So what would be common for every shape? Well, maybe I want to have an area method, and the area method is going to take in 2 integers into it. That would not be very good, but let's just say every shape has to have an area method, and it has to have those 2 things. Or maybe I want to have something a little different. Maybe I want to have a method that will not return anything but will translate the shape by some certain amount. So there are no implementation details here. But if I were to go into my square class and I were to now say that I want this to implement shape. Oh wow, I'm not typing very well today. And I want it to implement shape, you'll notice that this it's happy with, but it has created an error. And when I go into the error, it's going to say, you can't do this, because if you want to actually implement shape, you are going to have to implement all of those abstract methods. Abstract methods are those ones that you didn't give any sort of a body to. So in order to make this work, I'm going to have to implement them. And you'll notice that NetBeans is nice enough to create the structure, but then it just throws an error in here, which means I have to put something useful inside here in order to make it work properly. You'll also notice it's kind enough to add this little notation, which is to remind us that this is actually overriding, or it's grabbing information from there. You kind of have to have this because you're trying to adhere to that. So that's fantastic. I'm so happy. I can also go to my rectangle, and I can also say that I want this one to implement shape. And look at that, we're super happy. So what? Well, one of the reasons so what is that if I come back to this main program here, I could, if I want, create an array based on the interface. So right, and if I want to, I can now make a spot of shapes, and I can make it equal to my square. And if I want, I can also take another spot in my array and make it equal to my rectangle, even though these are two separate objects, right? So two separate classes even. I'm able to put them into the same array because they are all part of shape. Even cooler, if I want, I can iterate through this loop, and I could say shapes at I dot area 2, 4, 3. Oops. So now what I'm doing is not only am I able to create an array and put different types of classes in there, but I'm able to call the area without actually knowing whether I'm calculating the area of a square or the area of a rectangle, because it doesn't matter. Because as long as it implements that interface, I know it has to have a method for area. I don't know that it works properly, but I know that it has to have it. And that's just a small glimpse into what makes this really powerful, and it's used quite a bit in Java. When we get into sorting, for example, you don't want to have to write a sorting algorithm for one type of data and then another completely different one for another type of data, and you don't want to keep making those implementations. If instead you can just write one sort algorithm using an interface and saying that anything else that you want to sort, as long as it uses this interface, you can use my sorting algorithm. And that's pretty powerful. I'm not going to demo abstract class here. The idea is very similar, is that when you've got the shape, instead of doing an interface, you would do an abstract class. And one of the big differences now is that if you wanted to, you would be able to have some methods that would potentially be able to have implementation details. And implementation details is not something that you can have, as you can see, inside an interface. But it is something that you could potentially have in an abstract class. Hopefully that makes a little bit of sense there. That concludes most of what we want to talk about with object-oriented programming. There might be a few little tidbits that we'll allude to here and there, but at this point you should be able to think in an object-oriented fashion. You should be able to create classes. You should be able to have constructors and methods. You know now how to inherit from other classes. And that is going to provide a lot of tools for working on some of the advanced projects that are to come. As usual, if you have any questions, comments, or concerns, toss it in the comments or into my chat. And otherwise, I wish you happy ooping.